Alright, let's break down the inverting amplifier, one of the most popular op-amp circuits out there. Here's the basic setup. You've got an input resistor, let's call it Rin, and a feedback resistor, Rf. The non-inverting terminal? That just gets grounded. Super simple. Now, the input signal is fed right into the inverting terminal through Rin, while Rf connects the output back to that same inverting terminal. This feedback loop is the magic behind how the circuit works. So, what makes it inverting? Whenever you put a positive voltage in, the output comes out negative. In other words, the output is a full 180 degrees out of phase with the input. Let's talk gain. The voltage gain formula for an ideal inverting amplifier is minus Rf over Rin. That minus sign? It's there to remind you the output flips the phase. Here's an example. Say Rf is 10k ohms and Rin is 2k ohms. Plug those in and you get a gain of -5. So a 1 volt input becomes a -5 volt output. What else should you know? The gain all depends on the ratio of those resistors, not their absolute values. The input impedance is basically just Rin, which makes calculations easy. And if you're into analog circuits or signal conditioning, you'll see this configuration everywhere. One last cool concept, virtual ground. Thanks to negative feedback, the inverting terminal stays at nearly 0 volts, even though it's not actually connected to ground. It acts like a ground in the circuit analysis, which is super handy. So that's the inverting amplifier. Simple, powerful, and everywhere in electronics.